Week 8, Lesson 2. Okay, so if you've already printed out this worksheet, there are 8 problems on it, grand total. I'm going to do 4 of them, 1 from each page in this video, and then you'll do the other ones. And the reason I'm doing 4 of them is because they're presented 4 different ways. All right, so on the first page, you are given the graph, and you have to answer all the questions. On the next page, they're given in vertex form, and you have to answer the questions. On the next page, they're given in standard form, and on the last page, they're given in intercept form. So I want you to have an idea of how to do each one, okay? So I'm going to do number 1 on page 1, and I'm just going to start by looking at the picture, and I'm seeing that I have a vertex down here. I believe this is at 3, -9. All right, and I'm going to check to see if this is a regular parabola. What I mean by that is the a value 1, or is it maybe taller, or maybe is it shorter? And the way to tell is, does it follow a regular pattern of x squared? Meaning, if I go to the right 1, I should go up 1 because 1 squared is 1. So far this is looking good. If I go over 2, 1, 2, I should go up 4. 1, 2, 3, 4, because 2 squared is 4. All right, next, if I go, let me get rid of that. If I go over 3, okay, and again, it doesn't matter whether I go left or right. If I go over 3, 1, 2, 3, do I go up 9, right? Because 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I do, okay? So I can tell right now, just by doing that quick little check, that the a value for this is going to be 1. Okay, so in vertex form, and I'm hoping this is review. Again, this is from Algebra 2. The a value is 1, and then we have x minus the x part of the vertex, right? X minus 3 squared, and then it's this number as the end part of the vertex form. I don't have a better way to say that, and I apologize. Okay, standard form I can get by actually foiling this, right? Foiling that, we get x squared minus 6x plus 9. Don't forget to bring this up, minus 9. So simplifying that, we get x squared minus 6x. Intercept form I can get by looking at where does this graph cross the x-axis. And it crosses here at 0, and it crosses here at 6. Okay, so the intercept form is a, which I still know is 1, and then it's x minus one of the roots and x minus the other root. Here, if you wanted to leave this part, let me highlight it. If you wanted to leave this part as just x, that's fine. Okay, next I'm looking at the axis of symmetry, which is this dotted line. Okay, that has an equation for it. The equation here is just x, sorry. Let me try that one more time. Highlight it. Okay, and then change, here we go. Axis of symmetry is x equals that line, which in this case is 3. The y-intercept is an ordered pair. I can see this parabola is crossing the y-axis right here at 0, 0. Concavity is just, does this thing open up or down? Okay, so this one is an upward facing parabola, right? If I filled that with soda, right, it would hold it in. It's concave up. Okay, next, this is asking, do I have a maximum or a minimum? Well, this parabola goes up forever. I'm never, ever, ever going to reach the top. So this one happens to have a minimum. You can see it. It's right down here. Okay, that minimum value, right, the actual number that describes that minimum is this y value. Okay, the zeros, we just talked about that. The zeros and the intercept form go hand in hand. The zeros are at 0 and at 6. The domain, right, this thing goes forever left and forever right. So it goes from -infinity to positive infinity, non-inclusive. And then the range on this one, the lowest value that I can find is -9, and it goes up to infinity, non-inclusive. Okay, so for the next page, I'm going to do problem 4. Okay, excuse me. Notice that this one, you have been given it in vertex form. Sorry, I forgot to switch to pen. Here we go, vertex form, which means I know my vertex is going to be at -3, 9, right? -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertex. Okay, I know the A value is -1. Okay, so that means this vertex, or excuse me, this parabola is opening down, and it's a standard parabola, which means, let me just tell you right now, if you go in there and do this, it looks like that. I'm going to mark it so wrong, you're going to end up with negative points. Okay, I am a huge fan, of a very accurate graph. Okay, I want to see every ordered pair that you can fit on this graph that I've given you, which means you can go over 1 and down 1 in both directions. You can go over 2 and down 1, 2, 3, 4 in both directions. You can go over 3 and down 9 in both directions. Oh, that's in the wrong spot. Let's make sure I fix that. Okay, I even think that this graph is big enough to go over 4 and down 16. 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4. 1, 2, 3, 4. Okay, notice, again, lots of ordered pairs. I'll even make them slightly bigger for you. And you can get a really nice, accurate parabola, okay? Nice, neat, and through the points. Okay, I'll be really picky. Okay, now, as far as standard form, all I have to do is FOIL. So let me FOIL, x squared plus 6x plus 9. Don't forget there's a negative out in front of there. And there's a plus 9 after it. And if I distribute and combine like terms, I should end up with -x squared plus 6x. Not plus 6x, minus 6x. Let me try that again. Minus 6x. Better. Okay, intercept form. All right, so let me start with the fact that I'm going to have y equals negative, right? That A value that you get out in front, you're going to have the same A value on all of them. Let me grab a highlighter really quick, right? I have an A value of -1 here, and here, and here. All right, now the intercepts here. I have one of them at x, or excuse me, at 0, and I have the other one at -6, which means this will be x plus 6. All right, let's see. The axis of symmetry has to go straight down through the middle of this parabola, so this will be x equals -3. The y-intercept, again, I can see it right here. It's at 0, 0. This is concave down. Right? It opens downward. This one has a maximum value, again, because these go down forever, and that maximum value is at 9. All right, the zeros, again, you can see them here and here. Maybe I should highlight those. I'll highlight them in green. There's a 0 there and a 0 there. They are at 0 and at -6. The domain is from -infinity to +infinity. And then the range, right, this has a maximum. So starting at the lowest value I can find, which is -infinity, I top out at my maximum value of 9. Okay, on the next page, I'm going to do number 5. Okay, number 5. All right, now, personally, I think standard form is probably the hardest one to do. But I'll tell you why, and I'll try to show you a trick or two. In standard form, this number right here at the end is the y-intercept. Okay, this only works for standard form. -8 should be my y-intercept. So let me draw that. 1, 2, 3, 4, 5, 6, 7, 8. There's my y-intercept. And while I'm at it, let me go ahead and name it right here. Okay. Next, for standard form, I can find the axis of symmetry by doing -b over 2a, or in this case, -2 over 2 times 1, which ends up being, what is that, -1? -1. Okay, so here's my axis of symmetry. Let me draw that in. Let me also write it in right here, x equals -1. Okay, now, my A value here is 1. This is a standard parabola, which means anytime that I go left and right a certain number, I'm going to go up and down that number squared. So if I go left 1, I'm going to go down 1, and there is my vertex. Okay, in fact, let me label that vertex. It's at -1, -9. Okay, once you know where the vertex is, you can write vertex form, right? I know the a value is 1. I do x minus the x part of the vertex, right, which ends up making it positive, and then minus the y part of the vertex. Okay, and for intercept form, I need to draw this picture, right? I need to draw more of it, all right? And we can fit a whole bunch of dots on this one. If I go over 2, I would go up 4. 1, 2, 3, 4 on both sides. If I go over 3, I go up 9 on both sides. If I go over 4, I go up 16, 11, 12, 13, 14, 15, 16 on both sides. Okay, so again, really nice, accurate, cleanly drawn parabola with a whole bunch of detail. And now in intercept form, I can see that I have a 0 here at 2. And I have another 0 here at -4. So there is intercept form. That's a 4, okay, not a 9. Okay, this is concave up. This one has a minimum. That minimum value, right, the lowest point here is -9. We just said what the zeros were. That's how we were able to get intercept form. They are at, hold on, sorry about that. They are at 2 and at -4. The domain, I'm going to just tell you a secret here for those of you actually listening to me. The domain is always going to be -infinity to positive infinity on up and downward facing parabolas. All right, and then the range, again, because this has a minimum, it starts at -9 inclusive and goes to infinity non-inclusive. All right, and for the last page, I think I will go ahead and do number 8. Okay, the very last problem. Keep in mind, when you turn this in, you need to have all 8 of these complete. Okay, so I know you may know how to do it and all, and that's fine. You can do it all on your own, but if you don't, you need to copy down what I've done in this video. Okay, so here we go. So here, intercept form means I need to set these equal to 0. So I'm going to have a 0 at 0. And here, if I set this a parentheses equal to 0, I have another one at -2. Okay, so those are 2 dots, which automatically means I know the zeros. They are at 0 and at -2. It also means that directly in between them is my axis of symmetry, x equals -1. Let's see, this a value of -3 means that this thing opens down, right? It's going to look like this. And it's 3 times as tall as, so this is the first one where I don't have, excuse me, I don't have an a value of 1. So instead of going over 1 and up 1, I'm actually going to go up 3 times as high. So over 1, up 1, 2, 3. There is my vertex. Okay, that vertex is at -1, 3. Okay, so now actually, I know I haven't drawn it in yet, but I could write my vertex form. It's y equals the a value, x minus the x part of the vertex, all right, plus the y part of the vertex. Let's see, if I distribute, actually this one, let me see if I can move this, give me a sec. Okay, here I need to FOIL this, which is x squared plus 2x plus 1. Then I need to distribute this -3. Don't forget there's a plus 3 at the end over here. So distributing, I have what? -3x squared minus 6x minus 3 plus 3. So combining like terms, my standard form is going to be -3x squared minus 6x. Okay, what am I missing? Ooh, the y-intercept, I can actually see that. It's at 0, 0. I can tell, again, I haven't drawn it yet, but I know this is concave down. When it's concave down, I always have a maximum. I can see what that maximum is. It's at 3. Ooh, the domain, based on my little hint, has to be from negative infinity to positive infinity. Let's see. Ooh, the range goes from negative infinity all the way up to that maximum value of 3. Now all I have left is to draw it. All right, so let's see. If I go over 2, usually that would mean I would go down 4. 2 squared is 4, right? But this thing is 3 times as tall. I have to actually go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on both sides. Okay, so this will be a very tall, skinny, facing downward parabola.